Hello, everyone, once again. This is lecture 2 of section 1. Welcome back. And in this lecture, what we will see is more details on how to complete a successful connection to the cluster, but also about more details on the structure of the cluster and how to operate on an HPC system. So let's jump into it. So the first thing that we will see is, after we have completed a successful connection to the HPC system, we will actually explore it and learn what type of nodes or computers are on the cluster, and what are the differences. We will also learn how to gather information from the cluster, but also who is behind the accessing uh, of HPC resources. And finally, we will learn how to edit files on the cluster, which is a pretty important piece of information that you will need in your research. Okay, so the first thing is, remember, when we say connecting to the remote machine or connecting to the cluster, we mean completing an SSH type of connection. So from your local device, you initiate an SSH type of connection, which if you are using a Mac OS system or Linux system, you should be good, as SSH comes with them. If you're using Windows, there are software, very nice software that you can download. One is Moba Xterm, one is the GitHub package, which comes with the shell itself. Um, Once you initiate this connection, you end up in the remote cluster somewhere. Okay, and so now we need to see how these actually work, because our idea of interacting with a computer is interacting with the graphical user interface with the screen. We have all the input devices that we know, the keyboard, the touchpad, and we are used to this type of interaction. But what we realize is that once the successful connection has been established, it will look something like what you see in the bottom. It's a very dull, very sad terminal line, but that means that you are physically connected to the remote cluster. Currently, for example, we connected to the Gram cluster at University of Waterloo, and we are in the login node number 2. So the first thing that we will do is actually describe the structure of the cluster itself. And what we will learn is that when you log in or you initiate a successful connection, you don't actually have access to the entire cluster, so to all the nodes in the cluster, but you actually are connected to a small portion of it, known as login nodes or head nodes. These are basically the access point to the cluster, and you will quickly discover that you are not the only one person probably logged into that node at that time. You will probably have many, many users currently connected there. And so what you will learn is that there are various type of nodes. I've described here 3 nodes. We will see probably a bit more into the course, but we have compute nodes. So compute nodes, think of them as workers. So those are the nodes that actually carry out the computations, like the numerical simulation. Login nodes, we have explained them. So these are the access point, and you do all the operation with them. You allocate resources and whatnot. And then some clusters have visualization nodes, which will be explained in the course what they serve, what purpose they serve. Um, so a very important piece of software is the scheduler, or the one that is used in compute canal clusters or alliance clusters is Slurm. So Slurm is an open source workload manager. What that means, think of it as a queue manager. So everybody is logged into the login nodes, and they are working on setting up their simulations. And then what they do is they submit their job or their simulation to the queue manager. And at this point, the queue manager decides based on priority, on the length of the job and whatnot, and whatever parameters, to allocate the resources or the compute nodes for to start the computation. Okay, so this is a very complex type of workflow, but basically this is how interacting with the cluster work, and this lecture will explain everything about it and will give you also extra external resources to learn even more. Um, Last thing that we want to discuss in this short video is how to edit files on the cluster, because once again, you might be used to having your very nice graphic editor, I don't know, Atom, for example, or VS Code or whatnot. But in this case, since most of the work on the cluster will be carried out without a graphic user interface, you might want to get used to some other types of editor. One of them that we highly recommend in this course is Vim or VI improved. It is a wonderful text editor based on command line based or line based, which has a no graphic user interface. So it basically pops up into your terminal line. You will quickly realize that the trackpad or mouse are completely useless when using Vim, and it's available in almost any Unix-based HPC system, and it is designed for high productivity. So trust me on this, the moment you know how to use a terminal or a terminal line text editor, it will be very hard to go back to using mouse or trackpad because it's a lot more efficient. Okay, so once again, I want to highlight the collaboration between MPI Lab, Computer Ontario, and University of Waterloo for this course, and I will see you next lecture.